Hi, we're going to talk about exponential functions. So an exponential function is a function that has a variable in the exponent's place. So this is the standard form, y equals a times b to the x power. I'm going to rewrite this to kind of show you that the exponent only goes with the b, not the a. So let me explain what these different parts of this form mean. So this a is actually your starting value when you're graphing. And it's your y-intercept. The b actually plays a bigger role in this. So the b describes how the function grows. So there's two different things that can happen here. Well, at least two for our purposes. So if b is between 0 and 1, not equal to 0 and 1, but between, let's say it's 1/2, 1/3, 9/10, anything between 0 and 1, it's going to be decaying. And if you think about your science class, when something decays, it kind of breaks down and gets smaller and smaller. Well, in math, that's what this is. So this graph would look something like that. Our values as x gets bigger get smaller and smaller and smaller. This is just an example of one graph. So that happens when b is between 0 and 1. Well, if b is bigger than 1, could be 2, 1.5, 100, we see growth. So that graph might look like this. And this is not a parabola. This actually continues to go straight, and it would go this way, getting closer and closer to 0. But that's just an example. So I'm going to graph one with you so you can see how we do it. So we are going to be graphing y equals 2 to the x power. For this, we're going to use a table, x and y table, and we're going to have a graph right here. Okay, so let's do numbers like -3, -2, -1, 0, 2, 3. So if I plug in -3, actually, you know what, let's start with 0 in the middle. 2 to the 0 power. Anything to 0 power is 1. 2 to the first power, that would just be 2. Let's graph these for now, and then we'll continue. So I'm going to make my little units. Okay, so 2 to the 0 power, I'm going to use a different color, is 1, so 0, 1 is right here. Now, if we looked at the little shortcuts we talked about up here, 2 is bigger than 1, and that's our b, right? b is the number to the x power. So we should know that it's going to be something like this. And our a, in this case, is an invisible 1. And that's what we see. It's starting at 1. That's our y-intercept. So it follows those rules. Alright, so let's continue. So we have 1, 2. So there's my x. There's my 2. Let's continue. 2 squared, 2 times 2 is 4. 2 to the 4th, let's see, would be right here. Could already kind of see the increase. 2 to the 3rd, that would be 2 times 2 times 2, 8. So 3 would be right there, 8. Right, I think so. Okay, let's do the negative numbers. 2 to the negative 1st. Well, anytime you have a negative exponent, remember you do the reciprocal. So 2 to the 1st is just 2, so this would be 1 over 2. So negative 1 and then 1/2 would be about here. 2 to the negative 2. Remember we flip it first, do the reciprocal. 2 squared is 4, so we would have 1 over 4. So that gets even closer. And then 2 to the negative 3rd, you flip it, it'd be 1 over 8. So that's even closer. We're not at 0, but we are getting closer and closer. So if we connect this, and let's put a little arrow here that it continues this way too, we could see this side doesn't get close. I mean, it gets closer and closer to 0, but doesn't touch 0. This one's just shooting right up. So this is a major increase. That's exponential growth. And this right here, you know how it's not crossing 0? This is what we call an asymptote. You'll see this next year in math, but it's basically a line that it doesn't cross. You could see there's no number that you can put for x that would make this be 0. So it will never touch this line, but it will get closer and closer. Okay, so that's basically how we graph it. Now your IXL that you have is asking you to find, actually identify different functions. So we just talked about an exponential function. I'm going to kind of roughly graph an example. So this is exponential. It's blowing right up. Or you can have it go the other way, where it's really decreasing. We have talked about quadratics. Remember, those are parabolas. So you can have it like this. It could be upside down, different ways. And then we've talked about linear functions. Those are just lines, so it doesn't matter which way. That would be a linear function. So you're kind of identifying them by looking at the graphs. If you have any questions, let me know. And like always, I'm available during office hours.